Welcome to all viewers for session 4. In this session, we will study with a new chapter, Simple Stresses and Strains under Strength of Materials. In last class, under first chapter, we studied the introduction of engineering mechanics. In that, we studied kinestatics, dynamics, and the behavior of the body under the different forces. And we also learned about the finding of resultant, finding the direction of a resultant, and finding the unknown force under the equilibrium condition. Further moving for the chapter number 2, we take up the chapter Simple Stresses and Strains. In this chapter, we are going to study the different characteristics of the materials and their behaviors in different conditions of loads, and we will try to find out their elongation, that is a strain, and different temperature stresses, and etc. Let us start with the new chapter Simple Stresses and Strain in session number 4. Introduction. What is a simple stresses and strain? To understand the behavior of various materials when subjected to load, we also learned in the last chapter the behavior of materials in static or dynamic conditions. In the materials, the elastic and plastic materials which undergo the changes or the deformation when they are subjected to different types of external loads. And the strength of material is the study of a behavior of a structure when it is loaded for different conditions. So, before going to this different types of loads, we will have to study the different characteristics or different behaviors of the materials. First, how the elastic body behaves. Elastic body is the ability of a body to return to its original shape and when the load is removed. Here initially we apply the load to the body. After loading, it tries to extend, it tries to elongate, and after the removing of external load, it regains its original shape, that is the characteristics of the elastic body. How the plastic bodies behave, in which the material undergo a permanent deformation under load, which do not have a tendency to regain its shape. The difference between elastic body and plastic body is, here in elastic body it tries to regain its shape, in plastic body it never come to its original shape. You can see in the pictures. See in the previous picture, the spring is pulled for a certain load, and after removing the load, the spring will come back to its normal position. See the rubber band here, it is pulled with the 2 fingers, then after pulling, it can come back to its original shape after removing the load or pull. Similarly, see the plastic person is bending a rod, and after bending, the ability of that bar which fails to regain its shape. Similarly, the clay is under a plastic condition, and after it is molded to the required shape, then it loses its ability to regain its shape. So, elastic body and plastic body, the last one is a rigid body. Rigid body is a solid body in which deformation is neglected, it never go for the deformation. Body does not change its shape, size under external forces or when force acts upon it. Either it will never be elastic or it will not be a plastic, it will be a solid body and which faces the external force. You can see in the diagram soft body and the rigid body. It can take any type of external load, and soft body, when it takes, either it may be elastic or plastic. As I told you initially, let us try to study the different mechanical properties of materials which are subjected to external loads and their behavior under the different external loads. What are those properties? Elasticity, plasticity, ductility, brittleness, malleability, toughness, hardness, strength, fatigue, creep. So there are around 10 properties: elasticity, plasticity, ductility, brittleness, malleability, toughness, hardness, strength, fatigue and creep. Let us study one by one so that it will help us in further behavior of a material when it is subjected to external load, that is stress or their deformation under strain. What exactly the elasticity? As we discussed earlier, there are three types of bodies which are elastic, plastic and rigid body, and their behaviors against the load. What exactly the elasticity? It is the property of a material which is having the ability to regain its original shape after removal of external load. When you remove the load, see there are examples of elasticity property. When the rubber is pulled, it is having the ability to come back to its original shape. You can observe these two, and up to certain limits it is having the certain limit, and if you pull still, it will come to the plastic stage and it will never come back to its original shape. So steel, aluminum, copper, etc., they are perfectly elastic up to certain limit, up to certain force. After certain force, they lose their elasticity property and they reach to plastic condition where they are failed to regain their original shape. And elastic property is again subdivided into homogeneity, isotropy and anisotropy. Elasticity means we study the different elastic properties in different conditions, in different directions, subjected to the type of load. Here, what is homogeneity? Homogeneity is a material having same composition throughout the body, having same elastic property at each every point. Body which is having same composition. Take a chalk piece, take a duster, take the rubber band, take the eraser. It is the property of a material where the composition is same throughout the body, and here we have to remember the elastic property at each and every point is same. Isotropy. Isotropy, material having equal and same in all direction, the elastic property is same. Anisotropy. Anisotropy is a material having a different elastic properties in different direction. The difference between isotropy and anisotropy is, here the elastic property is same in all direction, and in anisotropy it is different conditions under different directions. So elastic property is the property where the material tries to regain its original shape under a certain limit. Steel and aluminum, copper they are perfectly elastic at a certain limit. The second mechanical property of any other material is plasticity. What is plasticity? Plasticity in material does not gain its original shape after removal of the load. You have different types of example. As I told you, steel, plastic, copper, when they are pulled beyond their limit, their behavior changes from elastic to plastic. Every elastic material possesses the property of plasticity. Again I am repeating, steel, aluminum, copper, initially they behave in elastic condition. After the certain limit of their load, they change from elastic to plastic. It's an example you can see in the diagram or a pic. Ductility, the third important mechanical property, as we are discussing in the mechanical properties, elasticity, plasticity. The third one is ductility. What is ductility? It is a property of material which can be drawn into wires. Best examples: copper, aluminium, and wrought iron. It's not a pure iron. See here in the diagram, the particular maybe the material, it may be a copper or aluminium. They are pulled in equal opposite direction. Either they can cut into two pieces. If they are brittle, if they are very soft material, they try to be in the form of wire. You can see the electrical wire. Our electrical wire is made up of different copper wires and aluminiums. The particular copper can be pulled or drawn into required size of a wire or required length of the wire. It can be pulled up. The best example is gold also. Gold also can be pulled, make into number of wires, thin wires, thick wires, or according to their length requirement. It depends on the purity of the material. After discussing elasticity, plasticity and ductility, let us move to the brittleness. Brittleness, the good example for brittleness is our chalk piece. It is a property of a material which cannot be drawn into wires. Suddenly fracture appears when the load is applied. When you press a chalk piece, it will turn into number of pieces or it will turn into a powder form. It's a property of a material where suddenly it takes sudden fracture conditions, and the brittleness where the particular material cannot be drawn into wires. Cast iron, concrete, stone, chalk piece are the best examples of brittleness. So these are the properties. Why you have to study these properties? By studying these properties, we can exactly ascertain the behavior of the deformed bodies or the rigid bodies where we can exactly calculate their internal force to resist against the external force. It's an internal resistance or internal pull of the property of the material where it can resist any type of external loads. You can see in the diagram, a tablet is made into two pieces and suddenly fracture appears on the tablet. You can see the bulb, and there is the sudden deformation or the sudden fracture we can observe in the bulb when it is applied or when it is pressed. Malleability. It is a property of a material that enables it to get rolled into shapes. Shapes means any type of shape. Either it is a triangle, rectangle, circular, rhombus, or any required shapes and sheets. It is a property of a material that enables it to get rolled into shapes and sheets. So these are the property of material where they can sustain some of the elastic and plastic properties. When it is applied, initially at certain limits they behave like an elastic material, and after the certain limit they turn into plastic, and they may be in the form of ductility. Either they may take the form of a brittleness, either they take a form of a malleability, elasticity. So these are the different conditions of the particular material when it is subjected to load. The load condition is here very important. It possesses a high degree of plasticity and it is having a low strength. Gold, it can be molded into any type of sheets and also shapes. Next, toughness. The good example for the toughness is diamond. It can take any type of external load and it is having the ability of absorbing the energy and it never fractures. It is a property of a material by virtue of it is capable of taking any shock or impact. It cannot be changed into any shape. It can take any type of load. It can absorb any type of energy, and you cannot observe any fracture on the surface of the material. That is the property of the toughness material. Diamond is the best example for that. So here the toughness plays an important role, that is the property of that material which can resist, the internal property of the material which can resist any type of external force, and it can cut even other materials also. As I told you, it is a property of material by virtue of its is capable of resisting any shock or impact. It absorbs energy without fracture. You can observe here the alloy or a steel is pressed between the two loads. Here we can observe we cannot observe any type of a fracture, change in length, or the elasticity property or the ductility property of that material. See here, you can see here the tough and the brittle. As we discussed, what is the brittleness? Brittleness, it is the property of material. It is when subjected to load, it will be turned into number of pieces, or the fracture appearance on the particular material. That is the brittle, the property of a brittle material. You can see here toughness. If you try to bend it, it will never bend, and it is having the property of observing the energy or shock or impact. That is the property of a material. Hardness, it is the ability of a material to resist the indentation or surface abrasion. Surface abrasion means mark on the surface or the friction of the surface. Abrasion which resists plastic deformation. See here, the glass piece is taken, and you can it will be failed when we try to mark it on the particular surface, and it will never face any type of a friction. That is the property of a material. So here, what is that hardness? Hardness is the ability of material to resist indentation or surface abrasion. See here, you can observe the second diagram. Hardness testing. A load is applied on the particular material, and it tries to fail mark on the material, and very negligibly it will try to mark. That shows the property of material which will resist the load against the indentation or a surface abrasion. You can observe clearly the diagram, hardness against the glass and hardness testing. Coming to the next property, strength. What exactly the strength means? The strength of a material which enables to resist a fracture. You can see a person pushing the glass where the strength of the glass is negligible against the external load. If the glass having the resistance to sustain that load, then the property of that glass is said to be a strengthened material. You can observe the second diagram. Ultimate strength, it results in the fracture. If you put a more load, if you put a ultimate load, then there is a chances of a material getting into fracture. And if the strength is more, and definitely that material having the resistance against the external load. Strength itself, it show the meaning itself will show the strength of the material. Fatigue. As you observe here, when you go to any amusement rides, it will be connected with a chain link, and this chain will always try to take the repeated loads while number of rides. So when this particular material or the iron, the chain, when it is subjected to the repeated loads, and when after facing the number of repeated loads, the property of that material somewhere it tries to fail when it is lesser than the ultimate load. It does not require the ultimate load to get into fractured or get into failure. So here you can observe, you can see in the second diagram also, the particular material is subjected for a repeated loading, and it does not have to carry or the fail for the ultimate load. Okay, under subjected repetition of loads, the metal will get into two formats, or the metal will fail into under a fracture condition. So the fatigue, it is a property of material which fails at the load lesser than the ultimate load, for which the ultimate load is not required. For failure, ultimate load is not required, only it will fail when it is subjected to repeated load. Fatigue means the property of material which fails under the repeated load, when even though that load is lesser than the ultimate load. Creep. What is creep? When it is a property of material, solid material, which slowly deform or move permanently under long term of exposure. The best examples, the surface of road, the surface of concrete. See, when they are exposed for number of years, more than 10 years, 15 years, see, there is a chances of the surface abrasion, the chances of the material losing its strength, or the texture deformation, texture losure. So you can see here the surface of concrete, it tries to fail when it is subjected to load after their lifespan, or the slowly as their age is going under. See here number of cracks observed in the concrete surface, and you can see the concrete, or the number of joints against the side of a concrete road. You can observe the crack, and there is where we can say it is a creep of a concrete. That is, it is a property of a solid material which slowly deform or move permanently under long term exposure. And even the best example for creep is when rod, or the steel rod, is kept for the moisture content, kept outside for a long term, it will be turned to form under a rust condition. The rod can be rusted, it will change its color from the black to brown black, and where the chances of that material losing its property, or it may fail under, or the lesser than the ultimate load. So till now we have studied the properties of the mechanical properties of different mechanical properties of materials, that is elasticity, plasticity, ductility, brittleness, malleability, toughness, hardness, strength, fatigue, and creep. Elasticity, you know, it will regain its shape. Plasticity, it will never come back to its shape. Ductility, it can be drawn into number of wires, or the smallest diameter of wire. Brittleness, the property of material into a number of fractured pieces. Malleability, it can be drawn into shapes and sheets. Toughness, it is having the ability to absorb the energy or shock or impact. Hardness, it is the resistance against the indentation or the surface abrasion. Strength, ability of material resist against the fracture. And fatigue, even the load is lesser than the ultimate load, the repeated load make the materials into failure condition. Creep, it is the maximum useful period of a material where it tries to deform, or it tries to fail, or the surface cracks, and it tries to move from their original position. So these are the mechanical properties when are used to classify or to identify the material. So now we can easily find out which type of metal it is. Suppose if you take a chalk piece, the metal is brittle. If you take a gold metal, it may be a ductile material, or it may be a malleability material. If you take a glass piece, and the metal having the most hardness property. If you take a diamond is a most tougher material. If you take a concrete, either it may be a fatigue material, either it may be creep material, and initially it behaves like elastic material, and later on it will be changed into plastic material. So by studying these property, definitely we will learn to identify or the classify different types of materials, and by studying this definitely we can calculate the different stresses and strain that material is going to face. So what exactly these materials behave when they are subjected to different loads and forces? The external loads acting on that body, or the internal force, or the dead load, or the live load, or the wind load, or the earthquake effect and fluid pressures, and different conditions, load conditions, how that particular material and especially the property of material when their behavior against the external force. See here, loads and forces. External force acting on a rigid body termed as a load. So different types of loads you can observe there in the diagram. Dead load of the building or dead load of a slab, it is transferred to beam or rafters, and those rafters will transfer the loads on the walls. That is the dead load. Dead load is acting on the building. The dead load means the self weight of the building which is acting on the earth, and after that we'll design for the different footing, and those footings will be designed on the safe bearing capacity of a soil. It depends on the soil also, on which soil this particular structure is standing. Dead load, live load, different types of live loads, maybe a movement of a person, movement of machineries, and different levels. You can see the live loads at a different levels. See, this is a dead load of pillars. These pillars carry the load of a beam, and these beams carry the load of a slab, and these pillars transfer their load on the foundation, and this is how the dead load, the transformation of dead load which reaches till the foundation of the building. Live load, as I told you, the movement of a machineries or the man. Okay. Wind load. Here two types of wind loads. Wind load before reaching the structure, it is a positive wind load, and after crossing that there is a negative wind load. Earthquake effects. As we know, different zones face the different earthquake effects. So depending on the zone, we'll try to take the earthquake load, and we design to resist again at the quick earthquake or sudden untoward incident or untoward happening due to the earthquake. So usually the earthquake nowadays all the designs are considered for earthquake designs. Fluid pressure, normally the water pressure during maybe rainy conditions or the water storage beside the structure, and we have to consider those loads, and definitely under these loads and the behavior of the materials or the structure under different load conditions, and we have to calculate their stress and strains so that we can design them. Moving further, forces or pushes or pulls that we studied in the last chapter, Introduction to Engineering Mechanics. They are measured in Newton. Unbalanced forces change the way something is moving. We can observe the deformation. We can change the property of the material under different forces, or it depends on the magnitude of the force or the direction of the forces. So ultimately forces or pushes or pulls. So what are the different types of forces? As you see in the diagram, see there are four types. One is a compression, that is the equivalent opposite moving in the same direction, making the particular body or the material shorten. Tension, material equivalent opposite which are moving away from the direction of the force. Here moving towards the direction of force. In tension, you can observe two arrows which are equal and moving opposite from the direction of force, and try to elongate this body. You can observe there is a compression force, this is a tension force, and see the third one, torsion force. It tries to rotate the body maybe clockwise or anti-clockwise. See the bending force here, despite of that pivot or the support, the force is trying to act in different conditions. Now bending, this force try to bend this particular material, that is called as bending force. And observing further, you can see the tension. Man tries to pull that particular material and making that material elongated. After pulling, definitely the original shape of the body changes. It may be now in the under tension condition, it will be the length of material will be very long, or least the change in length. Now you can see the compression. Here the metal is being pushed, or there will be chances of metal getting into shorten, or the change in volume, it may be a lesser volume. You can observe in the diagram, tension is pulling, compression is pushing, torsion. Here you can see he tries to rotate that. The best example is the cloth. When cloth after cleaning, we will keep for drying. Before that, we will try to remove that water by torsional effect. See here, it is being rotated in clockwise and anti-clockwise. Shear, two materials when they are lapped and they try to pull against their surfaces, there the force of the both materials are acting in parallel direction. It may be away or it may be towards. Here the surface of both materials are parallel to each other. Bending force, here when it is subjected to loading condition, the body tries to bend. You can observe here in the diagram. Then studying detail of the force which points towards its point of application, compressive force. The force which points away from its point of application is tensile force. Force which acts tangentially or parallel to the surface, shear force. So three important force we are going to learn in the further parts of the chapter. Here as I told you, what exactly the compressive force? The point of application is towards. Here the point of application is away. It is towards is a compressive, away is the tensile, and parallel is shear. For compressive you have to remember towards, for tensile you have to remember away, for shear tangentially or parallel. If you remember these points, then we can define these three forces easily. Compressive force, tensile, shear. Compressive means towards a point, tensile means away from the point, shear force tangentially or parallel to the surface. So further defining of these forces, you can see the shear force. Okay, it tries to change the topmost layer with as I told you, the surfaces of this particular material acting parallel to the surfaces. Compression force, when the force is applied on the body, the body tries to resist. You can see there is an internal resist of the body. The force is moving towards the point of application. Okay, and almost perpendicular to the surface, and it tries to shorten the body, and here the internal forces are acting towards it. See the tension, as I told you, the force which is acting away from the point of application, and here the tension force try to elongate. You can see the size here initially it is equal, and here it tries to elongate that. Even see here the compression, initially the size of material is the normal, and in the second pick you can see it tries to shorten or the lesser volume of the box or the body. Shear, it changes its length at the topmost layers. Here there is a resistance between the layers which are acting tangentially or parallelly, forces which are acting towards to the point of application. Here the forces which are acting away from the point of application. Now we will come into the mainstream of the main part of the chapter, where we are going to study the simple stresses and strains. Till now we have studied about the different mechanical properties and their behaviors against the different load conditions and different forces, that is compressive, tensile and shear forces. So these are the different external forces, and against these external forces we have also studied the behavior of or the different mechanical properties which can sustain these loads or their behavior against these different types of loads. Now coming to the main part, as I told you, the chapter name itself is simple stresses and strains. First one, stress. What is a stress? It is a force of resistance offered by a body per unit. I am repeating, it is the force of resistance, that is the property of material where it can resist the external force. I am repeating, the force of resistance offered by a body per unit area. So name itself specify what is the stress. It is a force of resistance offered by a body per unit area. Next, stress is a physical quantity that expresses the internal forces when external load is applied. When load is suddenly applied, we can observe the behavior of the body in the form of internal force and their resistance to the external force. So stress is the property of, here it is a force of the resisting force of the body when external force is applied. And normally stress, it is denoted by sigma, you can see here. So in throughout our problems we denote this sigma for a stress. The denomination for the stress is sigma. So as I told you initially, the force of resistance offered by a body per unit area, that is stress denoted by sigma, and here the ratio is applied for, and the force is applied against the unit area. Unit area means cross sectional area. Then the sigma is P by A. P means applied force and area means cross sectional area. So sigma is denoted for stress. So therefore stress sigma is equal to P by A. This is a formula. And importantly, here we observe the different types of problems where we'll have to learn the different types of units of stresses. So normally force P expressed in Newton or kilonewton. So this is an important part for solving the different conditions, different types of problems under the stresses. Force P expressed in Newton or kilonewton in this particular chapter. Cross sectional area A expressed in mm square or meter square. So therefore the unit of force is definitely load by area. Load means Newton, area means mm square. Either it may be Newton per mm square, Newton per meter square or kilonewton per meter square, load by area. So P is expressed in Newton or kilonewton, area represented by mm square or meter square. So overall the unit of stress is Newton per mm square or Newton per meter square or kilonewton per meter square. Both they are represented in different conditions. For smaller dimensions we take this Newton per mm square. For larger and larger quantities we try to take in meter square. For larger load conditions we will take the kilonewton, for larger length we will take meter square. So before that, what exactly the Pascal means? 1 Pascal is equal to 1 Newton per meter square. You have to remember, this is very important. 1 Pascal is equal to 1 Newton per meter square, or 1 PA. It can be represented by like this also, 1 PA, Pascal. PA means Pascal. As I told you in the previous slide, for larger quantities we will try to represent, or we define the stress in the form of kilo, mega, giga and tera. So as I told you, larger quantities of stresses are represented in kilo, mega, giga and tera. What exactly kilo? Kilo means 10 raised to 3. You have to remember, it's a very easy thing. Mega 10 raised to 6, giga 10 raised to 9, tera 10 raised to 12. These are represented by K for kilo, M for mega, G for giga, T for tera. So these are the quantities, or the large quantities we can represent stress in this format. Now as I told you in the earlier slide, what exactly the Pascal means? The Pascal is 1 Newton per meter square, or 1 PA. Now let us define 10 raised to 6 Newton per meter square. As I told you in the previous slide, 10 raised to 6 represent mega. See here in the previous slide, what is 10 raised to 6? Mega. Now replace that 10 raised to 6 to mega. So 10 raised to 6 is equal to 1 mega Pascal, so 1 MPa. Similarly 10 raised to 9 Newton per meter square, giga is 10 raised to 9, 1 GPa, 1 MPa. You can represent kilo also in 1 kPa. So we have not mentioned here. 10 raised to 12 Newton per meter square. Now you replace this 10 raised to 12 and replace with 1 tera. As I told you, 1 tera is 10 raised to 12. So you represent with T. So 1 tera Pascal. 1 Pascal, 1 megapascal, 1 gigapascal, 1 terapascal. 1 gigapascal means 10 raised to 6 Newton per meter square, or 10 raised to 9 Newton per meter square. For 1 TPA, 1 tera, 10 raised to 12 Newton per meter square. So usually for our condition, our types of problem, different types of problems, we usually normally follow this relation: 1 Newton per meter square, 10 raised to 6 Newton per meter square. As I told you, 10 raised to 6 is megapascal, 1 MPa, or 1 mega Newton per meter square. Mega is again Newton per m square. So remember, usually stress is represented in the form of Newton mm square, Newton meter square, or kilonewton per meter cube. And most of our problem we will try to solve with these relations, Newton per mm square or Newton per meter square, and some of the problems we can observe in the form of kilonewton also. Remember this relation, 1 Newton per mm square, and if you remember, this is enough. 1 Pascal is equal to 1 Newton per meter square, and for large quantities, as I told you, kilo, mega, giga, tera, 10 raised to 3, 10 raised to 6, 10 raised to 9, 10 raised to 12 for K, M, G, T. You have to represent with them the particular notations. Next, coming to the types of stresses. What are the different types of stresses? Tensile stresses, compressive stresses, shearing stresses, bearing stresses, bending stresses, twisting or torsional stresses. Particularly in this chapter, we will study in detail of tensile stresses, compressive stresses, shearing stresses, and we'll also try to solve the different simple problems based on those three forces. See here what exactly the simple resolution of forces. As I told you earlier, the different types of forces, okay, compression, tension and shear. Now coming to the stresses, what is a stress? It is a force of resistance, that is the internal force of the body which tries to resist the force of a external load. Stress is very simple, it is internal force or the force of resistance of a body which faces the external load, that is called as stress. I told you compressive force. Now here the stresses is compression stress or compressive stress, that is the inner force of the body. We will study further what exactly compressive force, compression, tension, shear. These are the simple resolution of forces or stresses. Coming to this, these are the complex torsion, flexure and diametral torsion or tension. This we will study in the higher part of the strength of material. For our curriculum, for our part of syllabus, we will try to cover in detail of these stresses, what exactly the compression, tension and shear mean. Tension, as I told you, the point of application is moving away from the force or the body here towards, and shear sliding of the two pieces of the body or tangential or parallel of these two surfaces, tensional stress, compressional stress and shear stress. These are the three forces we study in detail in our chapter. What is normal stress? Normal stress, it is the internal force and the corresponding stress acts in the direction perpendicular to the surface. Normal means, normal itself, the meaning itself is perpendicular. Here you can observe, for any external load, the internal force or the resistance force acting perpendicular to the surface. You can see here the particular surface which is acting perpendicular to the surface. Normal means perpendicular or 90 degrees. You can see here shear, which is acting side of the surface. This is called as it is not called as a normal, which is not perpendicular to the surface. I am repeating, internal force and corresponding stress acting in the direction of perpendicular to the surface. Under normal, again these, as we studied what is tensile and compression. So these are the two important stresses which come under normal stress. What is the normal stress? The force or stress acting perpendicular to the surface. Under this, tensile and compressive, and shear force which is acting parallel or tangential to the surface. What is tensile stress? Tensile stress or a tension is a stress leading to expansion, which will pull the body, which will elongate the body, which will deform the body by elongating it or changing its length or making the length more. Tensile stress is a stress state leading to, major thing is leading to expansion. The length of a material tends to increase in the tensile stress. That length of material tends to increase in the tensile direction. Body is subjected to two equal and opposite pulls. Three important terms. One is tension means pull, tends to increase, leading to expansion. Three important terms. Tensile stress means leading to expansion, tends to increase, two equal and opposite pulls. Pull, tension means pull and tends to increase leading to expansion. So this is the same formula as in stress. As you told, tensile stress is applied tensile force by cross sectional area. It is same as the formula of the stress P by A, only the load condition here is different. What is the load condition here or the force type? It is tensile force, and cross sectional area remains the same, the definition of cross sectional area. Examples, here the pulling up of the force P. See, this is very important. The resistance offered by the body or the internal force, the resistance R is equal to P. Here specifically, see here the material or the body is facing the tensile stress. See the resistance force in the diagram B, and similarly P dash the resisting force, and when the pull, the body try to resist, and this is called the force of resistance or the internal force or the stress against the external load. Coming to the compressive stress. Compressive stress is a stress on a material that leads to, here, see here, in tensile force it tries to expand or tries to increase. Here in compressive, that leads to smaller value, the size of that particular material decreases, no expansion, it comes inside. Body is subject to two equal and opposite pushes. In tensile it is pull, here in compression it is pushes, causing the shortening in the direction of force. Their expansion, here it is shortening, their elongation, here it is shortening. There in tensile it is pull, in compression it is push. There it is more volume, here it is smaller volume. Same formula as a stress, but the thing is the force is compressive force. In tensile it is a tensile force, in normal it is a normal force, and cross sectional area tries to remain same. The difference between the previous, see here in this tensile diagram force, the forces are being pulled away. Here in this pushing towards the direction of the force. Same diagram, the direction of force is different. Here it is moving towards inside, resistance of the force. See the direction. See the direction in the tensile, it is away. If the force is away, this is also away, and if it is towards, it is also towards. Internal resistance, see the direction. You have to practice this diagram for defining the compressive stress. So this is a very good example to, it is a self-explanatory. You can define the compressive stress easily. Shearing stress, it is a force that causes a layer or a parts to slide upon each other in opposite direction. Sliding, slices, okay, parallel to each layer or parallel to each other, they are acting tangentially or parallelly. Body subject to two equal and opposite forces acting parallelly or tangentially. It is denoted by tau. As I told you, shearing force is equal to P by A. See the diagrammatic representation. Two layers of forces acting in opposite direction which are parallel or tangential. This is a single shear, and this is the double shear. And if you observe it in the diagram, the further diagram, the layers are split into A into B and C into D. Here the force is acting in the left direction. See the resisting force acting in a right direction. Similarly, the top piece CD, the top force is acting towards the right direction, the resisting force is against the left direction. So in the stress, I'll repeat what stress is. Stress, it is the internal resisting force which will face the external load, and there are three types importantly. One is tensile stress, second one is compressive stress, third one is compressive stress, and all the stress are represented by the unit Newton per mm square, load by area, or further Newton per meter square, kilonewton per meter square, and for the larger quantities giga, mega, kilo, mega, giga and tera. So I have to represent these units in the larger quantities, and in next class we will learn about what strain means. Thank you.